Let's see if we could solve some word problems using greatest common factor. So here I have a problem. Miss Trencher has 8 pencils and 12 erasers. Okay, so let's write down 8 pencils. I'm going to put P for pencils and 12 erasers. I'm going to put E for erasers. She wants to make little gift bags so that each of her students has supplies. Each bag must be identical, just to be fair. So what I'm going to do is I'm going to highlight that they must be identical. I should have done this before. Highlight 8 pencils and 12 erasers. What is the greatest number of gift bags? So I want to find the greatest number of gift bags that she can make so that the bags are, again, identical. And I want to know how many of each supply will be in each bag. So we can do trial and error. We can try to make little pictures of bags, which I would advise that you do if you just want to understand what's going on in the problem. But here the problem is that you might look at this and think, oh, this is a division problem, but there's no divisors, okay? We don't know how many bags we want, but we have 2 dividends. We have 8 pencils and 12 erasers, and we know that those must be divided evenly among the bags. Well, when you have a situation like this, what you want to do is you want to do your upside down division. Okay? And what you want to do is you want to pull out the greatest common factor, which will tell you the greatest number of gift bags. So here I can see, let's say, I know that they have a 2 in common. So 2 goes into 8 4 times. I'm going to bring down the P for pencils. 2 goes into 12 6 times. I'm going to bring down the E for erasers. Now, what I have right now is that Miss Trencher can make 2 bags. Okay, she can make 2 bags, and each bag would have 4 pencils and 6 erasers. And that would be fine, except for the question says what is the greatest number of bags, and that's how you know you want the greatest common factor. I see that 4 and 6 are both even, so I know that I can divide them by 2 again, and 2 goes into 4 2 times, so I have 2p because I'm going to bring the pencils down, and 2 goes into 6 3 times, so that would make 3 erasers. Anything else in common other than 1? No, 2 and 3 are what we call relatively prime. So I see that the greatest common factor equals 2 times 2, which equals 4. Now, this 4 is the number of bags. So we have 4 bags. That's the greatest number of bags to ensure that each bag can be filled with the same number of pencils and the same number of erasers. So the greatest common factor tells us how many bags. And now look at this. You see this? This actually, we left the labels because this is telling us what goes in each bag. We have 4 bags, and each bag has 2 pencils and 3 erasers. And you can do any problem that is looking for greatest common factor like that. So let's take one more. Okay, a flower shop gets a shipment of 30 lilies and 27 roses. The employee wants to make as many bouquets as she can. That means the greatest number of bouquets. She wants to use all the flowers and have none left over. That's a clear sign that this is a greatest common factor problem. All the bouquets must be the same. Again, We want the maximum number, but they all have to be the same greatest common factor problem. Okay, another hint, when you see the greatest number, what is the greatest number of bouquets that she can make? And in addition, we have a second question, how many of each kind of flower? And again, that's why I'm going to be labeling these. Well, you should always label stuff, okay? That's a big thing in math. Okay, so we're starting with 30 lilies, and that's the way I write my L's, and 27 roses. Okay, again, two divisors, no dividend. I have to come up with my own dividend. Something, a number that will go evenly, divide evenly into both of these without a remainder. And I look, the first thing that comes to my mind is 3, okay? So 3, and 3 goes into 30 10 times, and 3 goes into 27 9 times. And if you look, 10 and 9 have no factors in common other than 1. So I'm finished. I can't do any more division. I can't pull out any more common factors. And so the answer is that she can make 3 bouquets. And you know, a bouquet is just a grouping of flowers like that you hold in your hand in a wedding. So 3 bouquets, and each bouquet will have 10 lilies and 9 roses. So those are nice big bouquets, but she can only make 3 of them. So these are just 2 examples of when we can use greatest common factor to solve word problems.